here's my understanding of this. There could be things that are off, right? So whenever we do a Rust program, whenever we do a thing with with the cargo toml, and we have our main src main rs, under main rs we generally have fn main right, and we have something like this guy can be in the code font, can be smaller, right? So generally we have something like println hey. Okay, this is a typical Rust program. So what happens when this runs? Generally this guy needs to, I'm just gonna make it like this and make it smaller. Cool. So the way this runs generally is, first of all, this pulls in the Rust standard library. Go back to this same font, Rust standard library, okay, which has stuff like files, it has stuff like network, it has your standard in, out, it has various things, right? It has threads, it has other things that basically are all OS wrappers, right? That is what it has. So we cannot use any of that. That's the point. That's point number one. Okay. Second, it's not just that, it even has things like libc, libopenSSH, openSSL, right? It has C stuff as well. So all of these things we cannot use because none of this will run by default, right? This is the first thing. Now, second, the compiler needs to know what happens when a program crashes. Okay, so in a C case, generally what happens when a program crashes, you get a code dump, right? You get a segmentation fault. Here's a seg fault. Okay, so in Rust, what happens is we have a panic that is called for some reason, right? It could be unwrap, right? We have these things which basically causes this gives you a stack trace, right? So it basically gives you a stack trace which has something 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 line number something 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 something. We have this, right? So this has things like unwinding. You must have seen this arrest backtrace a and b variable and all those things, right? So all of that stuff is done by the Rust runtime and the Rust compiler. Saying the word Rust runtime is weird because generally when you think of runtimes in Rust, it's something like Tokio for the async runtime, but even the general Rust programs needs a runtime. So when we do this, right? So okay, we'll get back to that. This is one. Secondly, okay, this is one part that we have to take care of. Another thing, right? So when I compile this, generally when I compile this, okay, on Linux, let's say, so what I get is a ELF binary, right? Or if you are a Windows person, I don't even want to comment on that right now, you get an exe, right? So this thing, right, it has essentially, it's no longer Rust code. Okay, so our operating system that is running it, when OS runs this bin, I don't know, let's call it app, right? There is no main. That's not how it works. So generally it looks for a thing called start, which is a function that is present in our ELF binary, which the OS calls. And this is what actually starts a program. This is the second part. Now what happens within the Rust runtime, like whatever is included in the standard library part of it, is this. So it has this, so what we actually do is, since there is no main, where do we get this start, right? So there is a C runtime, I think it's called CRT, which triggers this start thing, has this start thing, which then runs a Rust runtime, some runtime, which invokes our, which basically initializes the stack and a few other things, and then it does a, after all these things are done, it calls our main function basically, right? So this is what generally happens.